Rahim. Assalamu alaikum. This is Jahangir Sumro, Assistant Professor, Electrical Engineering Department, Sakkar IB University. This is Lesson 2 and Part 2 of LabVIEW Core 1 training course. In this Lesson 2, Part 2, we will start from learning what is Boolean data. Actually, as already described, that in Boolean data type there are only two states, either true or false. So it can be either 1 or 0. Use Boolean controls and indicators to enter and display in Boolean true-false values. LabVIEW stores Boolean data as 8-bit values. If the 8-bit value is 0, the Boolean value is false. Any non-zero value represents the true. Now, after understanding Boolean, it can be Boolean search, it can be Boolean latch, there can be different Boolean data types. Now we will understand mechanical actions of Boolean controls. Actually, Boolean control has different mechanical actions. Total 6 mechanical actions are there. We will study those mechanical actions. Alright.
After completing this module, Mechanical Actions of Boolean Controls, you will be able to use Boolean controls with the appropriate mechanical action and behavior for your application.
Now, basically, you should know which mechanical action or Boolean control should you use in any particular situation or condition. So you can learn from here that which mechanical action is particularly suitable for your condition application. So we'll study different mechanical actions of Boolean controls. All right.
We encounter Boolean controls every day. Light switches, stop buttons, waiting to cross the street. There are virtually limitless uses for Boolean controls.
Alright, so yes, there are different kinds of switches in the real world and they have different behaviors and mechanical actions depending on their applications. Examples, light switches. Change state when the switch is flipped, the state stays until you flip the switch again. When you enter the room, you turn on the light, the light remains on until you again press the switch to turn it off. This is also one mechanical action that you do in your daily life regularly. Another action that you perform in daily life regularly is the buzzers and doorbells. Change the state on a button press. When you press the button, when the button is pressed, buzzers and doorbells are turned on. They change back when the button is released. This is also one mechanical action. So in this lesson, you will study different mechanical actions of Boolean controls in LabVIEW.
In LabVIEW, there are many options for Boolean controls with several styles of buttons and switches to choose from. Mouse over each Boolean control type to explore your options for placing Boolean controls and indicators.
Now see, these are the different, this is a Boolean subpalette. In Boolean subpalette, there are different switches, push button, round LED, square LED. These are different Boolean numeric and Boolean controls and Boolean indicators in the Boolean subpalette. Now in these Boolean controls, there are 6 mechanical actions that we will discuss. Alright.
Boolean controls in LabVIEW can be configured to have different behaviors depending upon the application. For example, you may want to configure a stop button control to be immediately true when you press the mouse button. You may also want to ensure that the true value is read by LabVIEW at least once. These behaviors are called mechanical actions. There are 6 mechanical actions to choose from. To select a mechanical action for a Boolean control, right-click on the control on the front panel and select Mechanical Action from the shortcut menu. Mechanical actions can be divided into 2 main behaviors, switch and latch. Switch mechanical actions change the value of a control immediately when the user presses or releases the mouse button. A switch holds its value until the next time you press or release the mouse button, regardless of how many times the value is read by LabVIEW. Latch mechanical actions change the value of the control immediately when the user presses or releases the mouse button. Unlike the switch action, a latch retains that value until LabVIEW reads the control. Then the control returns to its initial value. There are 3 mechanical actions for switching and 3 for latching. Let's take a closer look.
Okay, here from you should understand one thing, that the total there are 6 mechanical actions. 3 mechanical actions are related to switching, and whereas the 3 mechanical actions are related to latching. So three switching options are switch when press, switch when release, and switch until release. And three latching mechanical actions are latch when pressed, latch when released, latch until release. Now, at this point, you should understand one main difference between switching and latching action. Actually, switching action changes the value when the event occurs, and it holds that event. Whereas in latch, what happens that it holds the value until the control is read by the value. Once the control value is read by the value, it reverts back to its initial position. This is the difference between switching action and latching action. That in switch, let me show you here. See, in switching action, it retains the new value until you click the control again. Like in the case of switch when pressed, what happens in switch when pressed? It is used as a control that changes the current value as soon as you click the control. Like when you enter the room, you turn on the light switch. Once you turn on the light switch, the light will remain on until and unless again you press that light button to turn it off. In this case, one point should be considered and should be clear, that the value of the control will be retained until you again click it to change its current position. But this is not the case with latch option. What happens in latch? In latch, you use as a control that changes the current value as soon as you click the control, and reverts the previous value after the VI reads the control. Once it reads that control value, after that it reverts back to its original position. Take an example of emergency stop button. Once you press the emergency stop button, as soon as you press the button resets as soon as the system reads the change in value, allowing for the button to be pressed again. It means that once it reads that someone has pressed the emergency stop button, it will execute this function. It will be it will be read by the circuit. Once it is executed, it will turn back, it will revert back to its original position to be ready for any user to press it again. This is the main difference between switching and latching action. Let me show you here with one VI example. Now you see here, when I turn on this VI, now this is the switch when pressed. Now when I press it, simply just I press it, the counting is on. It continuously counts. It remains in this position. It will continue to remain in this position until the user clicks this Boolean control again to change its position. Now I go here, I click it. When I press it, it again changes its position and counting is now off. This is the switch when pressed action. Now come to latch when pressed. In latch when pressed, when you press it, it changes the state on a button press. Change back when the control is read by value. Once it is read by value it for one time, then it will again revert back to its original position. See, when I press it, it is read by value one time, and again it goes to back its off state. This this is what sometimes you want. Let us say if you want to stop the while loop, when you click the stop button, it should be read once, and again it should revert to its original position. So in this scenario, you should select the operation of the Boolean control as latch when pressed. Okay, let me make it more simple for you. Actually, switch when press button is same as you press caps lock button on your keyboard. When you press caps lock button of your keyboard, the caps lock button will be continuously on. All the writing that you will write will be capital, unless and until again you press the caps lock to revert to its original position. This is what this action is called, switch when pressed. So caps lock is same as working as switch when pressed analogy. Alright, another example. Now see, let me show you. Now once I turn on the caps lock button, now my caps lock button is on. Whatever I write, it will be in capital letter, and this action will continue until and unless I again press the caps lock to change its existing position and to change it to in its initial position. When I again turn it on, and then now it will be small letters. All right. Now let me give you the example of latch when pressed. Latch when pressed is simply like when you press any other key like alphabet key, like say suppose if you press H, it is it is typed only for once. It is read only once, and for typing again you again need to press it. This is same as latch when pressed action. All right. So I defined two examples. One is the this example analogy, and other analogy is that switch when pressed has the analogy of here. Switch when pressed has analogy of light switch, and switch and latch when pressed has analogy of emergency stop button. All right. Now now let's move ahead. Now this from this point you should be basically clear about the main difference between switching and latching action. All right.
Click on each mechanical action to learn more about it.
Okay.
With the Switch When Pressed mechanical action selected, the value changes immediately when the mouse button is pressed. The control retains its value until the button is pressed again. This mechanical action is similar to flipping a light switch on a wall to turn on a light. It's important to note that each of these mechanical actions are merely approximated by the graphical representation of the control's behavior. The physical action of you clicking or releasing the button on your mouse is where the actual value change is triggered.
Okay, let me show you here. Let me show you here. Now in this VI, what happens that stop button is connected to a condition terminal, and let me turn on this VI. Now you see where, okay, first of all go to stop, right click stop button, go to mechanical action and press switch when pressed. Now you see when I will press this switch, this button, the VI is stopped, and it will remain in this position, in stop position, until you click it again. When you click it again, it will change its position. This is what switch when press action is. See, when you press stop, it is still stop. When you run the VI, it will not execute because the stop button will be continuously pressed until and unless you again press this button to change its position. This action is called switch when pressed. Now let us see. Now let us see latch when pressed. All right.
Latch when pressed changes the control value when you press the mouse button and retains the new value until the VI reads it the first time. At this point, the control reverts to its default value, even if you keep pressing the mouse button. This behavior is similar to a circuit breaker. It is useful for stopping a while loop or for getting the VI to perform an action only once each time you set the control.
Yes. So when you want to stop this, let us say loop, while loop. So let us say now change this mechanical action to latch when pressed. So when you will press it, it will be read by this program only once. Once it is read, it will go back to its original position because original state. Because in latching, it is read by the review, and once it is read, then it changes to its original position. Now let's see. When I press the stop button, program stops, and again it goes back to its original position. This is a difference between latching action and mechanical action. Okay, let me show you again in this VI as well. So when I press it in switch when press, when I press this button, counting will be on. It will be on until and unless I change this position again. When I press it again, it will be off. But in latch when pressed, when I press it, it will read once by the review, and then it will revert back to its original position. This is the difference between switch when pressed and latch when pressed. All right. Now let's move ahead.
Switch when released is similar to switch when pressed. However, it causes the value of the control to change only after you release the mouse button.
All right. So let me show you here. Now let's change this mechanical action to switch when release. When I change it to switch when release, when I turn it on, this will not change position until I release it. if I have not released, now until the point I have released, the switching action will not be performed. Switching action will be only performed once I release it. See, I release, the switching action will be performed now, and it will remain in the same position until you click it again. So this is a switch when released. Let me show you in this VI as well. Now you see, this is switch when released. So when I release it, until I release, only the counting will start when I release it. If I do not release it, you see counting is not started and the LED is still not on. When now I am releasing it, you see the counting is now on. So this is switch when released. And to change its position again, I need to hold it, and when I will release, it will change its position again. This is the action switch when released. So analogy of switch when release is when you use checkbox. The checkbox changes its value only after you release the mouse button, which gives you the ability to reconsider your choice after clicking by moving the cursor away from the checkbox before releasing the mouse button. How? Let me show you here. When it is switch when release, now see, if I move it here, counting will not start. So you have option whether you want to continue with your decision or you want to withdraw your decision. So if I press here and I move it here, then the action of the switching when release will not be performed. So user has option that user can move the cursor away from the checkbox before releasing the mouse button. Alright, to reconsider the choice. Okay. Now let's come to understanding the
Latch, when
latch when
released,
released.
changes the control value only after you release the mouse button and retains the value until the VI reads it the first time. Then the control reverts to its default value. This behavior works in the same manner as dialog box buttons and system buttons.
Okay. So let me show you latch when released. Okay. When I will release the button, only then the action will be performed in latch when release. Still, I have not released the button, therefore the action is not performed. Let me, right now I am releasing. Now you see action is performed and it is performed for only one time. Once the value reads its value, then it reverts back to its original position. This is what happens when latch when release is pressed. So how can you differentiate between latch when pressed and latch when release? In latch when pressed, the action will be performed when the button is pressed. But in latch when release, the action will be performed when the button is released. So this is the difference. Alright. Okay. Now let's move ahead to
Switch
switch
until
until
released
released.
changes the control value immediately when you click the mouse button and retains the new value until the button is released. Then the control reverts to its default value, similar to the operation of a door buzzer.
Yes, door buzzer is the best example. Now what happens? Door buzzer, until you release the door button, door buzzer it will be on. Once you release the door button, door buzzer, then door button will be off. This happens uh, in this switch until release function. So let me show you here. So this is switch until release, and doorbell is this example. The bell rings as soon as you press the button and continues to ring until you release the button. Now you see here. This is switch and until release. Now counting is on until it is released. Switch until release. When I leave the button, you see counting stops and it reverts back to its original position. See, again I want to turn on the counting. I the switching action will be performed until it is released, like in the doorbell example. Now it is continuously pressed. It changes the state on a button press, changes back when the button is released. Now I have not released the button. When I release the button, it will change back its position. Now see, I release the button. Once I release, counting will be stopped. This is what switch until release function is. Okay. Okay. Another is the latch until released.
Latch until released changes the control value when you press the mouse button and retains the value until the VI reads it once or you release the mouse button, depending upon which one occurs last.
Okay, now you see Latch until release changes the state on a button press, change back when released, and read by LabVIEW. Once it is read by LabVIEW or you release it, whatever is the last, that will be executed. Now see, it counting is on, it will remain on, and it will change back when released. Now let me release it. It will be edit it will be read by the LabVIEW and then it will stop. So these two, search until release and latch until release, have very similar functionalities. So this is what mechanical actions of Boolean controls are there in LabVIEW. There are 6 mechanical actions in Boolean control. 3 are related to switching, other 3 are related to latching. Thank you very much. We will continue our lesson 2 in third part of LabVIEW Core 1 training. Thank you.